So, hello everybody. So before coming here, we have discussed with Rutger and Stefan that the focus of this session should be how to build a solution. So what are cryptographical functions you can use, engineering tricks, these kind of things. So we are not here today to discuss if this is going to be the future. We are here today to discuss what's the best way to build this future. Hallelujah. Sorry, I had to do that. All right. So with that being said, oh yeah, there. Basically, I'm here to share with you my experience at the Blockathon, which was an hackathon organized by the European Union on how to fight counterfeits and fake goods thanks to the blockchain. So, I don't know, where? Okay, sorry. Okay, so basically we will go through the problem description. So what's the supply chain of trust? What was our proposed solution? And why a second layer is arguably the best approach for this kind of solution and superior to in-house built products. And then I'll walk you through a little bit of how Ion Pass protocol works across the blockchains. So this is something you will see. And finally, at the workshop, I will speak a little bit about the workshop. So one first advice I want to give to you is choose wisely your name, because as you see, we were Team Cryptomize, very nice. And then you have to have corporate-ready supply chain of trust security solution with the name Cryptomize. No, it was impossible. So we changed the name. It's called Ion Pass now, but we will get there. So basically, imagine you are a brand. Your products are distributed, so they are brought to the front door of your consumers by a third party. Call it Amazon or Alibaba or whatever. So basically, this third party decide what product is authentic, what not, what do they deliver, what not. You have 0% stake in this company. You have no visibility in how they take this decision. So this is when you need a blockchain approach. For instance, earlier last year, end of 2017, beginning of 2018, the Birkenstock CEO removed all the product for Amazon and went on to say that Amazon profits from selling fakes. Now that things have changed, and of course Amazon responded and prepared a task force to deal with that, but still, when you have a brand, you cannot trust and today you are trusting someone to distribute your goods, and you have no idea what are they doing with them. Okay, so when you have origin and transit certification, you can enable a list of use cases, like the circular economy, which is very important for the fashion industry. So you have to prove that your clothes are built from previous clothes. Of course, you can also help fighting counterfeits, and also you enable, in an easier way, some insurtech. So for instance, there was a very interesting case for KLM, which was flying batteries from Hong Kong to Europe. And basically, they need to know that the battery is authentic, because ion lithium batteries tend to, if they don't pass some quality certification, they blow up in flight. So basically, for them, it was very important to decide how risky a cargo was. And maybe this is something you will also see in other deep dive session about the insurtech. So understanding where the cargo is from and what's inside the cargo is very relevant to know how much you have to price the insurance for that cargo. So these are some examples of use cases you can enable by knowing the origin and the transit of your goods. Okay, so what was our solution? It starts very simple. We call it the virtual twin protocol. So basically, to every physical good, you also have a virtual one. And the reason is, in the physical world, you don't accept the real good if I cannot give to you also the virtual one. And the reason is that in the physical world, cloning an object can be difficult or easy, depending on your skill. But on the virtual world, within a blockchain, you can have mathematical proof of how difficult it is to clone or break a private key. So you can see quite simply, if we go in an ideal world where everyone accepts this protocol, you can see it's a Nash equilibrium. So let's say that I try to create a fake good or steal a good and sell it. No one will buy it because I cannot give to them also the virtual twin. So this removes, in the long term, removes economic incentives from creating fake goods and stealing. Of course, in the real world, we cannot be so naive and believe that everyone will just accept it. So we've built on top of it a reputation KPI that can be used by logistic operators and customs to basically decide who's the risky, if it's a risky shipment or a risky individual. So basically, the holders of the product, the chain of holders will be marked in a blockchain, and when something strange is found with the physical world, so maybe they declare that a shipment of cacao is arriving, but when the cargo arrives, the shipment is empty. So when something strange happens into the physical world, you can press a button, and the line of holders, the previous holders, become red. Repeated offenders in time will be crossed by these red lines. So the number of red line crossing an entity is going to be basically a reputation index which helps identify the riskier individuals. Oh. Wow. I'm lost in my presentation, but okay, we'll take it from here. Why a second layer approach is interesting for this problem? First of all, if you build it, if you conceive it properly, it can be technology agnostic, and don't underestimate the capitals that corporations are already investing today in a technology or another. So maybe someone is building their proof of concept in Ethereum, someone else is building it on Hyperledger, someone else on Bitcoin. So there are already investments being made in the corporate world. So you can come with your proprietary solution or your single blockchain solution. It could work, but you have to consider that there are already investments being made in pretty much, I don't want to say every blockchain, but in pretty much a lot of them. A second layer approach also allows for client-side validation of off-chain computation, which is very important, as also other speakers said. Because on the blockchain there should be the minimum, really the minimum necessary. So all the computation should be done offline, and then eventually you upload only the proof that you did the computation right. So the minimum you put on the on-chain, the better it is. This is a general approach for any blockchain. And finally, these things together allows you to create a high throughput environment. Because, for instance, this is the port of Rotterdam. If you cannot, you have to think that whatever solution you have in mind, it needs to scale. So you need to batch stuff together. You need to find ways to remove load from the chain. So you have to think like you can start with small examples, but you have to think how would it scale on a very huge volumes. Okay. So how did we build it? During the hackathon, we used Ethereum because it is very easy to you can develop quite straightforward. It is straightforward to develop a smart contract. We use the non-fungible token ones. So basically, every virtual twin is basically a token, and you pass around this token alongside with the good. Not limit, but something that we are still studying how to do it properly, is that it's very important for us to know the history of the holders. And Ethereum is an account-based system. It means that it has the real-time state of the accounts. So at a given point in time, you know who is owning what. But to reconstruct who was the previous owners, this is not built in the system. So in the following months, we also worked on a Bitcoin-based approach, which uses single-user seals. And we started on Bitcoin, but any blockchain which has the concept of unspent transaction output and transaction can use a single-use seal. Basically, it works like this. I declare to you that I will send this document with the hash of a document, and I put it and I also declare which unspent transaction output I will use, and you will tell me which will be your next transaction output that you will use. So when I spend my output, the document, the meaning of spending the output is committing forever on the blockchain that I'm sending to you this document with that transaction, and you will be able to send the document over to someone else spending that transaction. So basically, when you spend a transaction, you put a seal, and that something has happened. And this is very general. You can use it on Litecoin. Basically, any blockchain which has the concept of unspent transaction and spent transaction. This we will see a little bit later. I mean, probably in the workshop we will go through how it actually works. But if I am a party and I need to send to you my virtual twins, my shipments, I need to declare to you which blockchain I use and which is the commitment method I use. In ERC 721 is going to be the approve function. Maybe later someone will explain to you a little better. In the Bitcoin ecosystem, it's going to be I declare that I will use that UTXO to send out my documents. Then I have to prepare my document, and we are using files and hashing of files for this. The reason is that from a legal point of view, the concept of hash of a file is already accepted. Prosecutors already know that if a hash of a file exists, it means that at a certain point in time, that file was actually on some machinery. So from the legal point of view, using file and hashes, it's quite straightforward. And then you need to commit the sending of this document, basically either by doing the transfer function, or if you're using ERC 721, or by spending the transaction and putting the hash in the op return if you are using the other way. This is just a little preview of what we will see in the workshop. Everything that I will share with you is more of like food for thoughts or ideas on how to develop your solution. So this is basically how a document looks like in the EONPass protocol. Yeah, we will go through this in the workshop really. So basically, in the workshop, we will see how do you create the virtual twin, how do you pass it over from the producer, from the original brand, I should say the brand owner, to maybe the production facility or the logistic facility. Then how do you batch these virtual twins together? Because sending one token per product is not gonna scale. How do you split shipments? Because sometimes in the logistic industry you need to, you have a batch of 100 watches and you need to ship 50 one way, 50 the other way. So you have to be able to split shipments. You should ask, well, then you should also be able to compact shipments. Yes, but we are not, it's not as necessary, so we didn't really write the implementation of it yet. And so basically, this is the ASCII art they referred. We were choose wisely your name. If it's gonna be cute but not work in a business environment, don't use it. And 30 seconds, yeah, sure.